cloud. All right. So we're gonna just recap 1.3 again, the word problems. Again, if you watch the video, that's great. If you didn't, that's okay too. But if you think about it, when you have a word problem, you have to make an equation. You have to understand what you don't know, like what you're trying to solve, right? What's the actual question asking for? Give it a variable, and then try to come up with a verbal model if that helps, right? Like, for example, if the bill for repairing a bike is $180, they give you the invoice, right? You go to a bike store, you got to fix it, they give you an invoice. You're trying to, see what they actually charge you for, right? You're going to see that, well, $105 for the cost of parts. So the parts plus labor equals the total cost, right? So if you need to write that out, that's fine. If you can just visualize it, that's cool too. Like, yeah, this is what I have to do. I have to add these two things to get the total cost. What are the cost of parts? $105. Now the labor is hourly, right? What's the rate for labor? 25. How many hours did he work? I got no idea. Call it X. Whatever you don't know, call it X. But if you multiply it by 25, that's going to get you the cost of labor, right? Like if the guy worked 10 hours on your bike, that's $250, right? That you got to pay for labor. And all that has to equal 180. At that point, I know you can solve the equation because we did solving yesterday, right? So, and you guys have done this like so many times. You've done this in Algebra 1, you've done it pre-algebra, you've done it in geometry, right? So I'm not worried about solving equations. I'm just more worried about knowing how to set it up, right? So that's how you do part E. Just come with a verbal model, substitute what you know, make sure you use a variable for anything that's unknown, make sense of it, and you're fine. All's good, right? Let's look at F. Percentages can be a little wonky sometimes, but if you think about it, if you work at a restaurant, you're told that you get a flat rate. Okay, so your flat wage plus whatever tips you get, waiters, waitresses, they work for tips, equals your total pay. Well, the flat wage is $45, right? Now, how much money did the person make in tips? Well, the tips is determined by percentage, right? If you ever go to a restaurant, they always say like what the tip, right? They give you a percentage in the bill. So 15% of the food bill. Well, the question is, what's the total number of the food bill, right? I don't know. Call it X. You're getting 15% of that. Like, let's say you've served some people and the bill comes out $100, and you get $15, right? But you have to multiply that percentage to X. Remember, percentages are decimals, right? 15% is 0.15. You just move the decimal point 2 places to the left or divide by 100. So 0.15x equals 120. And you solve it. At that point, I know you guys can solve. I'm not worried about that. Same thing here for if you go to a bookstore and you have to pay tax, right? Or wherever you go, right? You got to pay tax. So the cost before tax, because you maybe look at the back side of the book and you're like, oh, okay, this is the cost of the book plus the tax equals the total cost, right? Well, the cost of I don't know. And call it X. I have no idea. The total cost 17.28. Now I think about it, what's the percent tax you're charged? 8%. How do you write 8% as a decimal? Point. That's right, thanks. Okay, 0.08. Just gotta get my voice a break sometimes. And it's 8% of what? Of the cost of the book, right? Before tax. So that's how you have to do it. X plus 0.08x equals that. And then you solve for X, and it's not that hard. But if you break it down that way, these word problems are very, very manageable, right? They're not that bad. And you work it out. So that's how you figure it out. And then lastly, this is actually really kind of interesting because I think there's actually some changes to commission for real estate these days. But yeah, real estate agents, I mean, they don't make much. Really, they actually, some of them don't even get a base salary unless they work for a big company. Actually, let me do this first. But they work for commission. So base salary plus commission equals a total pay. right? So what's the base salary? Of course, 22,000. What's the total pay? 60K. Commission is a percentage of what? Of your sales. Do I know the sales? I do not. That's gonna be like how many, not how many homes, but like the cost of all the homes they sold. If they sold like say 5 homes for $1 million each, then fine, $5 million, but they get a percentage of that sale, right? Install for X. There you go. I think it was 900,000 when I worked it out, but yeah, that's what we do. So you just set them up, solve it. Okay, any questions on that? No? Okay, so now let's move on to 1-4. So for 1-4, there's a bunch of different formulas here that we're going to look at. Distance equals rate times time. You should know that. If you don't know temperature, don't worry about it, but it's right there. And any of the formulas is really wonky. I know you guys had geometry already, but I think for the most part in Algebra 2, I think we'll give you the formulas. Don't worry about it. Don't like think, oh my God, I forgot all these. And just so you know, like, you guys remember like all those like wacky ones with like circles and like secants and arcs and like if you have like something like this here, hold on, just trying to remember. You guys remember this? Like that's A and B and C and D, right? Or you guys remember these? Like you have like this here, and they have this angle, and it's like some sort of combination of these other arcs, right? Don't worry, we don't expect you to know that stuff for Algebra 2. Don't worry about it. And even these here, we sometimes feel inclined to give these to you. On the SAT, for example, these are given to you. So don't worry about it. Memorization is actually the thing I despise. So I'll give you these things. But it's a matter of how do we work with these formulas. That's what I care more about, right? So let's look at part A. You want to solve for R in the circle circumference. So if you're given the formula, solve for R means isolate R. That's what it means. You want to isolate R. So it's all algebra, right? So C equals 2 pi R. And if it helps, I'll put these multiplication symbols. What's opposite of multiplication? Just a divide. There we go. Just do the opposite. Boom, boom. R equals C over 2 pi. Why does that matter? It seems trivial right now, but trust me, as you do move further along the map, most likely in pre-calculus, definitely in calculus for sure, you're going to have to be able to use a skill in a very fluid way. Like there'll be certain skills you have to do in calculus, which you guys are 2 years away from that. If you go down that path, where you have to get good at isolating variables to make the math easier to do. Because sometimes the math can get really crazy if you don't know how to isolate variables. So we need to be very fluid with that. So we're going to be working on that repeatedly. How do you isolate variables? Just do what's the opposite. 2 and pi be multiplied r, divide by 2 pi. And now r is by itself. You're good. Let's look at another one. Solve for B2 in the area of a trapezoid. The trapezoid is right here. Come on. Here we go. Well, let's rewrite the equation. Let's do this. What do you think I should multiply both sides by first? Because your goal is to get, let me highlight it. And this might be very obvious what to do, but I'm just going to take my time because I don't want to rush this. Okay. Can't tell. That's yellow. Okay. Choose a different color. But you want to get that by itself, right? So I need to get rid of this 1/2. I need to get rid of this H. I need to get rid of this B1. So it's 3 things I need to get rid of, right? The half, the B1, the H. What can I use my first step to kind of help alleviate, make this look nicer or more clean? Like, let's say that 1/2. I want to get rid of that 1/2. What's the opposite of multiplying by 1/2? Multiplying by 2, right? But multiply by 2, what's 1/2 times 2? Because you get 2 over 2, right? Yeah. So let's do that. Let's multiply both sides by 2. Or you could divide by H first if you wanted to. You could have done that as well. It's up to you. Let's multiply both sides by 2. So it's cancel because 2 over 2 is 1. So 2a equals parentheses, and please, please, please be OCD with parentheses. Do not be lax about it. Times h, okay? Now let's go to the h. What's the opposite of multiplying? Dividing, right? Just divide by h. So I do this, and I do this. So those cancel, right? Those are gone. Cool. So now I got this 2a over h equals b1 plus b2. Oh, geez. Let me switch colors. That's not good. Okay. And then lastly, how do I get rid of b1? Yep, subtract b1 from both sides. And that's it. We got it. Two a over h minus b1. All right, solve for w in the perimeter of a rectangle. And then afterwards, do that. Find the length when you have those values. So 2L plus 2W equals P. Our goal is to get that by itself. So what do? Subtract the 2L. And then divide the whole thing by 2. And you can leave it like that. You don't have to get too cute about it. Now, as you guys, hopefully you guys realize I think I'm a pretty chill, cool person. I do get worked up when this happens. Never, ever do this, please. So people say the answer is that. Why is that bad, what I just did? What rule did I just completely disobey? We talked about it yesterday, PEMDAS, order of operations. I completely disobeyed order of operations here. Because if you were to plug in something in for L, what would be the first thing you do? You multiply by the 2 there. Then you subtract P minus that. Then you divide afterwards. You're basically bypassing order of operations because what you're saying then is that this minus doesn't matter. You're saying that minus doesn't matter. But in essence, what's really happening? There's actually invisible parentheses here, believe it or not. If you were to type this into a calculator, you would actually have to type it in like this. If you type in like this, the calculator is going to divide the 2 by the 2 first, right? Because it doesn't realize that P minus 2 all one numerator. So you have to be very mindful about that. Because you would, like, for example, you would never do this. If you have 4 minus 3 times 5 over 3, can I cross off those 3's? No. If you do, you would get -1. You get 4 minus 5 is -1. But what is it really? It's actually 4 minus 15, which is -11 over 3, which is not -1. So if we don't deal with numbers, don't do that with letters. Please don't do that. So that's just one of my biggest pet peeves. Not much bothers me. That actually bugs the crap out of me. So don't do it, please. Just be mindful, know order of operations, be respectful about it. All's good. Just maintain that integrity. You're good. So that's the width. And now you can solve what they want. The perimeter is 41. L is 12. And you should get the answer. It should be 17 over 2, I think. Use a calculator if you need to, that's fine. But yeah, I think 17 over 2, that's the width. That's meters, by the way. So once you have the letter isolate, then you can plug in the numbers and solve for what you need to solve for. Fine, part D. Solve for R in the formula for circle's area. Well, what's the area of a circle? Pi r squared. Okay. So there's two things happening. Actually, I'm going to rewrite it like this. So R is being squared and also being multiplied by pi. What I think is the easiest thing to do is my first step. To help get R by itself in the right side. Because again, all the whole goal of this lesson right now is isolated variables. What should I do first? As my first step to get this by itself. Should I do something about pi or do something about square first? I think it's the easiest thing to do first. So what's the opposite of multiply? So we divided, all is good, right? In some ways, it's kind of the reverse of order of operations in some ways, because you're kind of undoing the multiplication first. See, if you square root, because opposite squaring is square rooting. If you're a square root, here's the problem. You got to square root that pi as well. You've just made this messier now. You actually made this worse. Actually, I don't even know how you would well, I do know how you undo it. You square, bring back, but it's just not a pathway you want to take. So we'll divide by pi first. And those cancel, right? Because something divided by itself is 1. And don't get lazy. Do show all the steps. Once you get very good at it, you can kind of just maybe do 2 or 3 steps at once, but you're not there yet. You're still trying to, you know, get more sophisticated with your math skills. So, show the steps. Once you get to calculus, if you could just see the answer, more power to you. But I prefer that you just be more detail oriented if you can be. And there you go. R equals root a over pi. So square root a over pi. Now, technically speaking, there should be a plus or minus. Because if you think about it, what if x squared equals 4? What could x equal? 2 or what other number? What other number when you multiply by itself becomes 4? 2 times 2 is 4, and what else? -2, right? Did you say -2 or no? Okay. Well, -2, right? Because -2, what's -2 times -2? 4, right? But how come, so you should be putting plus or minus when you square root to solve. You should be doing that. So x equals plus minus 2. But why would I not need a plus or minus for the radius? Why is it weird to have a negative value? Can a radius be negative? No, so it's a physical dimension, right? So just be mindful about that. Okay. So I'm gonna have you guys try a couple of these on your own before we move on to 1.5. Actually, why don't you try number 2 right now? I'll do 3 with you guys. So your goal is to get y by itself. And then find the value of y when x equals -5. Okay, so I'll give you guys about a minute to do that. I'll do as well. We'll check. Oh, right. I just realized I made a careless mistake. I'm gonna correct it right now. You guys get -13? Yeah, I got 9.5 accidentally. Here we go. I accidentally put 5. -5, so I corrected it. Actually, I did say like isolated variables is relevant as we want to pick calculus and how calculus. It's actually relevant now. You do want to be comfortable with rewriting this in slope intercept form. Because say I ask you to graph this equation. you could probably make a table where you can probably find intercepts, like, hey, we're putting 0 for y, solve for x, and stop putting 0 for x, solve for y. You could use the intercept method and plot those two intercepts and draw a line to those 2 points. But sometimes we want to isolate y to get the slope quickly, right? If you isolate y, that's y equals mx plus b form. We'll talk about lines, I think, probably Thursday or Friday, I think we're going to talk about lines. So that's m, 9/4, right? And that's b, -7/4, the y-intercept. So that's good to do as well, to be able to isolate variables, or for substitution. Next week, we'll talk about solving systems of equations. Substitution is a technique where you want to isolate one variable. So again, these are all techniques that are relevant now too, not just for the future. And then once you have that figured out, you can plug in -5. Now, could you plug in -5 right from the beginning and solve for y? Yes, you could have done that too. I didn't want you to. I want you to isolate. Because what if you had like a multi-step problem or multi-part problem, and they ask you to find a bunch of different values of y for a bunch of different values of x? Then it's good to actually have the equation isolate for y, and then just plug in all these different values for x afterwards. That could be much easier. Good. 3 is a tricky one. And I sometimes let a huge sigh here. We actually had to retest this, I think, 3 times last year. So I will say this: if you can figure this out, you will have a leg up over all your peers in Algebra 2 next year. At least I think, because this was a tricky one. And the way we go about CPM, or what we did last semester, is we don't really do retakes so much. Do you guys have retakes in geometry? How was retakes? How did it go last year for you guys? Do you guys have one retake a semester, 2, or you guys remember? What was the policy you guys had?
You're below like
Below 80, and then how many times were you allowed to retake? Okay, 1 every 3 tests. Yeah, that sounds about right. So we do something different in Algebra 2. And I think, well, we did do similar policy in Algebra 2. And then what happened was, I had about a dozen or so students. And it was kind of our fault because we were right before the midterm break, or the fall break, right? In October. And then so grades were due. So we had a test before that. And then we did the retake, I think, right around the same time. And almost everyone some people just gave up. They didn't want to do the retake, or or they just crashed and burned it. So the retake was a waste of time because I spent all this time writing it. They took the time to kind of take it. So it was a waste of time for everybody. So what we do now is our tests act as retakes. So like what we do is we have the first test, which covers whatever we just did. And the second test will cover old stuff and new stuff. And whatever you do on the old stuff will act as a retake. So we'd use that sub score on the new test to replace the score from the previous test, if that makes sense. So the point I'm trying to make is that a problem like this here, number 3, was a nuisance, was tough for some people. So we were constantly putting us on every test, and that was counting as a retest score for the previous test. So if you can figure this out right from the get-go, more power to you, because you're gonna have a leg up over everybody else. So you asked to solve for y. Okay, so let's talk about it. I'll get off my soapbox now. Let's talk about how do I. So y is here and here, right? So y occurs twice. So some students will do this. Don't write this down, by the way. This is bad stuff. Some students will try to move like this xy over, and then they'll divide the 2. And then they'll do some really weird crap. Like they'll like multiply by 1 over y and not do it to the other side. And they'll have this, which is wrong. This is really bad math I'm doing right now. So they'll do all these weird stuff. Stuff that actually sometimes I never even thought was imaginable. It's like, wow, that's pretty creative. It doesn't work. It doesn't work with the logic of math, because math, we have rules, right? So again, y occurs twice. So this is kind of our first foray into factoring for this class. You can factor out the y. Because what if I gave you that initially? If I gave you that initially, can that y be distributed? Yeah. If you distribute it, what would you get? Back to what you have originally, right? So that's totally valid. You can totally factor it out. If anything's common between 2 terms, like they have something in common, pull it out. You're good. So now y occurred twice, now y occurs once. Now I feel better about this, because y is being multiplied by 2 plus x. Well, what's the opposite of multiplication? Division. So divide by that whole group. That 2 plus x group is now one entity. You could divide it to the other side. Now you got it isolated. And how do I know it works? How do I know it makes sense? Well, say for example, let's try and think here. What if y were 2 and x were 1? You don't have to write this down. But if y were 2, you have 4 plus 1 times 2, which equals 6, right? 4 plus 2 is 6. Boom, boom, boom. We're good, right? Sweet. It works here as well, right? 2 equals 6 over 2 plus 1. That's totally valid. 2 does equal 6 over 3. 2 equals 2. We're good, right? So I know it makes sense because I respected the rules of algebra and the order of operations, right? I didn't disobey anything mathematically. Everything was done validly, right? So, we have validity to all this stuff. So now I could do the second part. Find what y equals and x equals -3. Easy. 6 over 2 plus -3. 6 over -1. -6. All is good. So we're okay. Okay. And why is it trickier? Because of vol factoring. Just a little more sophisticated skill we have to use here. Yeah, Manny, go ahead. -3. You can, that's fine. But I still want you to isolate y algebraically as well. You still have to do that. I mean, I'll make that requirement. But what if there was like 3 or 4 other parts and I asked you to solve for other values of y for other values of x? It's probably better to have y by itself first, and then you can use that repeatedly without having to solve multiple equations. So just a good habit to isolate the variable first. Let's come back to 4 in a little bit because 4 is a little funky. Let's look at 5. So how many times do you see z? So we know we have to do this factoring business, right? The problem is that these are opposite of the equation. For number 3, they're on the same side. So we have the luxury of just pulling it out right away and then divide by 2 plus x and we're done. Unfortunately, they're not on the same side, but it's not that hard. Just move the z over like that, right? Because you have a plus z, you got to subtract. Now let's pull it out. Now careful when you pull it out. It's xy minus 1. Think about it. If you put z back in, you gotta get back to this, right? So what I've seen some students do is that they pull the z out, and when they see a single z here, they don't think to put the -1. They just do that because they think it's gone completely, but that's not true. Because if you put the z back in, you need that -1. You need that minus z there, so you need a -1 as a placeholder. So you gotta respect that, just so you know. Because you put the z back in, you get back to the original expression. Like for example, if I have like 12 minus 4, right? I know the answer is 8. I could factor out 4 if I wanted to. It's kind of weird why I do it this way. I could do that. But notice that if I put the 4 back in, I need to get back to what I had originally. Or to make sure this is valid, 4 times 2 is 8. 12 minus 4 is 8. I gotta make sure it's valid. So now we're one step away. We're getting z by itself, just divide by what was in parentheses, and all is good. And there's nothing more you can do to simplify it. But you can't cross out these x's, you can't cross out these y's. Don't do that. Because you have the pluses and minuses between the variables. You got to just respect it. It's like there's like parentheses here. You would actually compute those first before you do division. So yeah, see like that. So again, you'll totally be in great shape if you just recognize, hey, let's collect all the terms. So let's just summarize here. Collect all the terms that contain the variable you are asked isolates. On one side of the equation. Factor out variable. Finally, that's precisely what we did. I put all terms on one side of the equation that contain the variable you're asked to isolate. You're asked to isolate z, so that's what I did. I factor out z, great, and divided both sides by whatever expression is next to it. That's precisely what I did. For number 3, I didn't have to step on because I was done from the array. The array were collected on one side, so that was fine. But for not, collect them all on one side. That's precisely it. And yeah, we had to retest this 3 times. I use a really funny analogy. What was the movie that came after The Dark Knight, the Batman movie? What was the one that came after that with Bane and Catwoman? You guys remember that movie? Anyone watched the Batman movies? No. Come on, no one's watched it. Oh, all right. Well, there's one scene where this guy's in a pit, but Batman, Bruce Wayne, he's in this giant pit, and he has to climb out of it, and he keeps falling down. And I kind of likened it to that, like, you guys are keep falling down, like you got to finally climb out of this pit. And they finally came out of it. It took 3 times to retest. So, okay, I'll think of an analogy that's more relatable to you guys next time. All right. Anyway, number 4. Now let's try this one here. You want to get y by itself. I'll subtract the 2x first. Actually, let's do this. I'm going to take a little different approach. We've talked about this already. When you have fractions, it's best to multiply by the denominator to get rid of the fractions. So I'll do that first. So you get 2xy plus 1 equals y. Because think about it. If I multiply y to this, that's 2xy. What happens y can go y can't get 1. And you get just y on this. And then just do what we've done already, right? What we've done already is we've collected the terms on one side, factored it out. That's going to be 1 minus 2x. And then divide by 1 minus 2x. So number 4, I think it's more challenging than 5. I don't know why we put in that order. But I'm being pretty consistent, right? Like I'm getting rid of fractions. We talked about yesterday, right? Like let's get rid of fractions by multiplying by the denominator to just make the column look nicer. Collect terms on one side, which I did. Have y in them. Pull it out and divide by that expression. Okay. Okay, then number 6. Okay, here's how to solve for the equation for y. Then find the value of y. Yeah, so that should be pretty easy. I'm going to add 3x to both sides. Y only occurs once in this case. And divide both sides by x. And then plug in 5. Which should be 55 over 5 or 11. I think that makes sense, right? Yep. Okay. Any questions so far? We're good? All right. So I'm kind of just thinking about pacing here. Let me just do one problem, just kind of get you guys thinking about it, and then we'll do a break because I see the other class has a break right now. So it could be a little distracting. Maybe want to hang out with them. So word problems. So again, this is kind of good because we talked about word problems in the video. We talked at the beginning of class today. Just read it first, kind of make sense of it. So Mark Watney was left on Mars due to a series of unfortunate events. I never read the book or watched the movie, but whatever. There was enough food to last the entire crew, 6 members for 56 days. We were 6 days in when all hell broke loose. That means that Mark is the only person left. The other 5 are dead. Okay. So it's 50 days left. And remaining food is enough to last a crew of 6 for 50 days. Okay. So how many days can Mark survive on Mars if he limited his daily calorie intake to 3/4 of the original amount? Okay. All right. Well, if you think about it, there are 50 days left and it's supposed to feed 6 people. So if you think about it, that could be 300 days for one person to survive. Does that make sense? Because what if it was just you and another person on a deserted island, right? And you had enough food for 20 days for you and this other person, and that person dies, or you kill the person or whatever. So then you have 40 days survival, right? Because there's now, like, maybe there's like, I don't know, 20 meal packs, or sorry, maybe it's 40 meal packs. That's why you and this other person survive for 20 days, but you kill that person or that person dies. So you have all those 40 meal packs to yourself. So now you can live for 40 days, right? So does that make sense? 300 days of survival, right? But he's reducing his caloric intake to 3/4 of the original amount. So what you want to do is you want to do 300 equals 3/4 times x, where x is the number of days. Because he's actually, you don't do 3/4 of 300, you do 3/4 of the days, because that's, wait, is that right? Am I doing that correctly? Yeah, I'm doing that correctly, yeah. Because that's going to actually tell us how many days, extra days he can live. So you multiply both sides by 4/3 by the reciprocal. So that's another technique you could do also, as that said divide by 3/4, multiply by the reciprocal. That also gets rid of the fractions. So if 5 people died, he could live longer, and also he's choosing to eat less. So probably be somewhat famished, but can live to 400 days. So let's go and stop there. It's 9:50, almost 9:55. If you guys come back around 10:05-ish, and we'll finish off the rest of these word problems, and then we'll do the problem sets after that. All right, so let's look at number 2. Mark decided to grow potatoes because he happened to be a botanist too. Mark estimated he would grow 150 kilograms of potatoes in 4 days. Potatoes have 770 calories per kilogram. How many days can Mark survive on potatoes if he needs 1,500 calories per day? Okay. So let me think about this one here. 150 kilograms. Okay. So trying to think of how I'd write an equation for this. I think I would just kind of just work out the math. I think that's what I would do. 150 kilograms, right? Times 770 calories per kilogram. Yeah, so let's do that first. So how many calories does he get? And I'll need a calculator for this one. Yeah, I'm not sure if I really make an equation of this one here. I think I'll just kind of just work out the math. I mean, I could force the issue of making an equation, but I think just work out the math is fine. But 1,500 calories per day. So then what I do is I do 1,500 calories in 1 day equals 115,500 calories over X days. So I'm doing some logic, right? I'm kind of realizing this is a ratio and it has to be proportional, right? So for example, 2 days we need 3,000 calories, right? 4 days we need 6,000 calories. 10 days you need 15,000 calories, and so forth. So if it gets this many calories, how many days can that be? So I would just set up like that. It's kind of like the classic, if you're standing by a tree, the tree is 20 feet tall, shadow's 40 feet long. If you're 6 feet tall, your shadow's 12 feet long, right? It's kind of like that kind of situation. So that's what I would do. So if I cross multiply, So you can cross multiply when you have one fraction on each side of an equation, and that's all you got. You can totally do that. So again, I'm just multiplying this, and this. It'd be 77 days. So I did make an equation eventually, but initially I did a conversion, and then I set up a proportion after that. Okay. So if that makes sense, we're okay with that. All right, just use logic. I think that's sometimes your best bet. Now let's look at 3. A novice Pokemon trainer, you need 10,000 XP to level up. Okay. You get 100 XP for every Pokemon you catch. If it's a new type of Pokemon, you get 500 XP. Let n be the number of new types of Pokemon you catch, or an expression for the total number of extra points you get for catching n types and new types. So every new type, you get 500. You get an extra 500. Ooh, okay. So I guess we have to do this. Write an expression. So it'll be 100 plus 500 times n. Sorry, I meant to use n. Because you get 100 XP for every Pokemon you catch. And if you get a new type, you get an extra 500. So 100 plus 500, or 600n. So you got to read it very carefully. And let P be the number of existing types of Pokemon to catch. Write an equation for getting enough XP level up from catching Pokemons alone. I guess the existing types. So that would just be 100p equals 10,000. So notice we did an expression for part A, but here we did an equation because you have to have an equal sign for an equation. And again, you're just catching existing types. So you're just using 100, not the 500, not doing new types. And you have to get the 10,000. Now solve for n and p if you've leveled up after catching 30 Pokemons. Okay. Well, hold on a sec. Oh, I got it. Okay. So n plus p equals 30. And then you're going to do this. Let me make sure I understand this question correct. Solve for n and p if you've leveled up after catching 30. Is it 30 existing or 30 total? I'm a little confused here. Give me a sec here. I think we're going to do this. The reason I'm hesitating is that this is something I'm not going to talk about next week. So I'm a little confused why this is in this section here. That's 2 equations, 2 variables, but the way I'm understanding this question, so I'm a little confused, but that's okay to be confused. I didn't write this problem, by the way, someone else wrote it. But I'm a little confused because I'm thinking what the questions tell me, and it should be worded better, is that you caught a total of 30 Pokemons, whether it's existing or new, combine the existing and new Pokemons, you caught 30. And of course, you want to get to 10,000 extra points. You get 100 points for just a normal Pokemon. You get 600 for new, right? Because 600, you get 100 plus extra 500, right? So I'm guessing this is what we have to do. Now, we haven't talked about how to solve system of equations yet. You guys probably seen this before, maybe in Algebra 1. We have 2 equations, 2 variables. Yes, or maybe in geometry, hopefully that got reinforced. Where we had to solve for 2 like angles or whatever, and you had 2 unknowns. Instead of doing this algebraically, I'm gonna go to Desmos right now. And do x plus y equals 30. And 100x plus 600y equals 10,000. Ah. And find where they touch. And I messed up x. There we go. Okay, perfect. Sounds good. Maybe that's what we're supposed to do. I don't know, because that number came out very clean. But notice I found the point of intersection, right? So I made my equations first, Then I use Desmos to do the math for me. Now we are going to talk about how to do this algebraically next week. And you guys probably already seen these techniques like elimination or substitution. Graphically, you can do as well if you do the graph correctly. But if you're going to solve graphically, I would much prefer use technology, because doing this by hand, our hands get a little, like not shaky, or we just don't do a straight line perfect unless you have a straight edge. Even if you do an immaculate graph, you might still be a little off. So Desmos is a little better if you're going to solve graphically, just punching the equations, look for the point of intersection. So 16, oh crap, did I mix it up? No, I didn't. No, we're good. So 16 existing and 14 new ones. There we go. Yeah, that makes sense, because P was existing and M was new, and or X or Y. So I probably should have rewritten like this. I was a little confused, but P plus N, N plus P, same thing. Doesn't matter. So okay, that's that one. So feel free to use Desmos if you want to. You can bust out a laptop if you got one. All right, we got a couple more, and then we're gonna do some the homework problems after that. All right, an SAT type problem. Ooh, okay. A car uses 16 gallons of gas to travel 460 miles. It gets 30 miles per gallon on the highway, 25 miles per gallon on city streets. How many gallons were used on the highway? Let's say an electric car. You're gonna put gas in your car, right? So here's what I'm gonna do. X will equal the number of gallons I think this is kind of lame. I don't like it. I'm just gonna get rid of it. It's confusing me. So I'm gonna, maybe we might need, I'll come back to it, but I think for now it's lame. X will be the number of gallons on the highway, because I don't know, right? And you're being asked to solve that. And Y will equal the number of gallons in the city. There's two things I don't know. But here's what I do know. X plus Y has to be 16, right? Because you have 16 gallons in your car. And part of those 16 is going to be used for the highway, part's going to be used for the city. And the assumption is that you use up all that gallons, right? Or this actually, they said to use it. So there you go. Fine. X plus Y equals 16. Now, the distance traveled on the highway plus in the city equals the total distance, right? What's the total distance we traveled? How far do we get? 460. Now, you get 30 miles per gallon. So 30x. Because let's say you use up 2 gallons on the highway. You get 160 miles, right? What if you use 10 gallons on the highway? Maybe 300 miles, right? So 30x is all the gallons, sorry, is all the miles we travel on the highway. And 25y is all the distance we travel in the city. Like, let's say you use up 2 gallons in the city, then you get 150 miles, right? Because you get 25 miles per gallon. So you get two equations here. 30x plus 25y equals 460. X plus y equals 16. I'm going to suggest use Desmos because we're going to practice solving these by hand next week. So I'm totally cool if you, I care more about the set than anything else. You get 12 and 4. So you spent 12 gallons on the highway, 4 gallons driving the city. And it makes sense because that adds up to 16, of course. Times that by 30, that's 360 miles you got on the highway. Times that by 25, that's 100 miles you got in the city. That's 460 miles. So, okay. Okay, last one, and then we could do some problems after that. You're hanging 3 pictures on a wall that's 16 feet wide. The widths are 2, 3, and 4 feet. You want the same amount of space between the facing pictures. You also want the amount of space on the ends to be 6 inches more than the space in between the pictures. How do you position it? Actually, this is a real life situation. I put up pictures of my house, and I have to do it correctly, or my wife gets a little annoyed. So you have this, and you have this. I'm gonna try to draw a little more scale. So this is X, and let's do this here. So drawing helps sometimes. If you convert 6 inches to a foot, 6 inches is what in terms of feet? How many inches to a foot? 12? Good. So 6 would be half, right? So that's gonna be half a foot. So you're gonna write this as X plus half. Then each of these here, that's 2, 3, and 4. And the whole thing is 16 feet, right? Okay. This is lovely. This is exactly what you want to do. We've done a visual model, right? What's my equation, guys? How do I run how would I write my equation? What do you guys think? What will be on one side of the equation? Perfect, good. What will be on the other side? This plus this plus this plus this plus this plus this plus this. So 7 things I'm adding, right? I mean, sure, you can consolidate 2 plus 3 plus 4 is 9. 4x, half and half is 1. But just so you see in all its glory, 16 equals x plus half plus 2 plus x plus 3 plus x plus 4 plus x plus half. I literally actually do this when I put pictures in the house, like to make sure it's all spaced correctly. So that's 4x plus 10 if you do it correctly. 2 plus 3 plus 4 and half should be 10. 6 equals 4x. I mean, this do by hand. You don't have to use Desmos to solve that. Like, that's just easy. So x got to be 1.5 feet, which is 18 inches. So I got to make sure I space these by 1.5 feet. And then I got to make sure it's 2 feet left. The left, far left, far right. And then my pictures are up, spaced out nicely. So we drew a picture and we solved it. So that's huge. That really helps you tremendously in solving these word problems. Or just come with a verbal model, which I did for number 4. And C was a little funky. I didn't like the wording of it, but I think I assumed it correctly. Perfect. So it's 10:30. So I'd like you guys to do go to homework problem sets. Let's see. We're supposed to solve for y. Let's not do 9 and 10. Let's do 1.4. The problems we're leaving out, we can come back to them later. So section 1.4. Let's do numbers 1 through 8. in section 1.5, let's do numbers 3 through 8. So it's 14 total problems. I totally think you guys can tackle this in the time we have left. So yeah, and then the answers are here. Work each other, help each other out. Let me at least get Schoology set up, and I'll have to do the video. So the video will be on just an overview of 1.6 and 1.7, so it should be pretty brief. Yeah. Use that. Okay.